Hello again. I've got a bit of a problem, and let me explain. I've got LEDs running, which are currently running off a plug socket up there with 5 volts, but I've got LEDs running. I've got controllers running, which also run on 5 volts. But then I might want to split the LEDs, so I might use something like a splitter like this, which runs on 12 volts. So then I have to have a transformer for the 12 volts as well. So I've got 5 volts, 12 volts, and I've got a 5 volt transformer over here which is running over here. And by the time I want to add any more LEDs in, it all gets a bit messy, it all gets a bit busy. So we need something a little bit better that's going to give me 5 volts as well as 12 volts, but not clutter the desk like this. So let's have a look at let's have a look at an alternative and see if we can get it to work and the reasons behind it. I need to clear my desk. Just a minute, let me see if this works. Right, that's better. Let's just move the USS Defiant off the desk. There we go. Right, so what can we use that's going to give us 12 volts and 5 volts at the same time? Well, me and Mrs. Mike's LED shed was in the garage the other day having a bit of a clear out. We decided to take some stuff to the tip. In there was a computer, a PC, and I thought, hang on a minute, this gives out both 5 volts and 12 volts out of here. This powers a PC board, and this powers the CPU, and then we've got outputs for the disk drives or CD players or anything like that. So I took this out of the PC, and then the rest of it went to the big PC field in the sky. So what can this output? Well, let's have a quick look. Let's see if I can zoom into this so to show you. There we go. So at the top we've got 3.3 volts that it can output, 5 volts, 12 volts and minus 12 volts as well. So there's quite a lot there that it can output, and on the 5 volts and the 3 volts you can see that we've got quite a few amps there that we can actually use. That's quite enough to power an LED matrix or something like that. So what is the easiest way of getting this clump of cable to give us the required outputs that we need? Well, funny you should say that, because I went on eBay, not eBay, sorry, I went on Amazon and I bought this. I quite like this because, let me zoom in a bit to show you. There we go. So this is a ATX power supply socket on here. More importantly, it's fused as well, which is good for protecting our circuits. We've got an on-off switch, again very good, LED to let us know when it's on. But here it's split as well. So we've got plus 12 volts ground, plus 12 volts, sorry, I've got that wrong, it's minus 12 volts on ground, plus 12 on ground, plus 5 on ground, plus 3 and ground. So on the plus 3, if you're using Arduinos or Raspberry Pis or something like that, that's handy, the 3.3 volt, 5 volt for your LEDs, 12 volt for any other controllers, etc. But not content with that, I thought, well, there's got to be more available than that, and there surely is. So I also bought this here. So I haven't opened this yet, so let's have a quick look at this. Again, we've got an ATX power supply that goes on here, but now as you can see we've got a lot more connections on it. So what have we got? We've got an LED here, we've got a switch by the looks of things, yep. Ground is there, 3.3, more ground, 5 volt, and that says power on there. We've also got 12 volt ground, minus 12, minus 5, and ground volt. Ground. And that's not fused. That's important to remember, that it hasn't got a fuse on it. So that's them two. And I also found this as well. So let's have a look at this one. Right, so we have the ATX supply here, LED as there. We've also got fuses, which is important, and we've got screw connections on here. And it says, okay, so we've got 3.3 ground, 5 volt ground, 5 volt ground, minus 12 ground, and 12 volt plus on there. So there we go. So as you can see, this is quite similar to this because it's got screw connections, not as many as this, but where these two have fuses, this one doesn't. They've all got LEDs to show that they're on. So I think the next thing we need to do is actually connect power, switch these on, and do a little bit of testing. Okay, let's bring in our power supply. Plug the mains in, just there. We're going to use this one first. So let's connect that up. Right, let's switch that on. Turn it on here. Yep, and we've got an LED light that's come on. Let's get our tester. Okay, hopefully you can see that all right. There we go. Right, let's stick ground on there. And we should have 3.3 volts there. There we go, 3.3. That's ground, 5 volts. Yep, ground, plus 12. Yep, ground, and then minus 12. Minus 11.3, that's close enough. So yeah, that's working a-okay, and all the power is coming out absolutely fine. Right, let's switch that off. Oh, that's tough. Here we go. Put that to one side. Let's bring this one in next. Right, okay. So again, let's switch that on. And there's no light come on. Oh, there's the switch. So switch in the middle. Okay, so now we've got power on. So let's test this. Okay, second one in is ground. So we should have 12 volt on there. Yep. Minus 12 volt. Yep, ground, plus 5. Yep. Ground, plus 5, ground, and 3. Yep, that's working fine. Could you see that? I can't remember if you could or not, so apologies if you couldn't see that, but just to show you, there you go. Right, okay, so that one's okay. Switch that off. Oh. And then finally this one. This is going to be a bit more difficult to test, but I can't quite see what's on there, but I'll do my best. Right, power, yes. LEDs come on, yes. So we've got ground, and then we've got 3.3, yeah, ground. 5 volt, yep, that's okay. And then we've got ground in the middle, 12 volt that side, yep. Minus 12, yep. Minus 5 if it's available. It's not available on this one, that's okay. So yep, that's working absolutely fine. Switch that off. Switch it off at the wall. Oh, and take that out. Right, okay. So as you can see, this would be quite good for powering both LEDs, controllers, and other things as well that requires 12 volts. So I think the next thing we need to do is set up some sort of test for this. So I'm going to, let me think, I think I'm going to use this one. This would be the easiest one to use because of the screw connections there. So I'm going to set up my controller on 5 volts. I can also set up some LEDs on 5 volts, and then I can set up the splitter on 12 volts. So let's have a look at the LEDs first. Right, okay, so this uses power, which is here. Right, before I go any further, so what I've done is I've connected this red cable to the 12 volt output from there, and I've put it into one of these Wango connections, and I've connected the 5 volts to this. I know it looks like earth cable, but it's just a bit of spare cable that I've got, which is connected to this one as well. Before I go any further, what I want to do, just double check to make sure that I'm plugged into the right connections. So let's get a test meter, cables, plug that into there. And we're just going to double check to make sure that we are in fact connecting to the right outputs. So second one in is ground, that's okay. So the first one should be 12 volts. Yep, it is. Sorry, you can't see that. Is that better? 12 volts, yep. And then the one we connect to here should be 5 volts. Yep, that's connected to 5 volts. That's okay. Get that over there, switch that off. Right, so we know that this cable, which is an earth cable but it's fine for testing, is going to be 5 volts, and then this one, which is connected to the 12 volts. Now the controller that I'm using, the SmartShow ProOne, does allow 5 to 24 volts, so I can run that happily on 12 volts, so that's okay. But my LEDs, which are here, whoops, there we go, can only work on 5 volts. If I put 12 volts through there, then we'll know that they're going to blow. So what I need is a connection to go on the end of that one. So get my boxes out. So I want one of them. That's going to connect onto that. Yep. which will give me output from the ProOne to here. So let's just strip a bit of that cable. And oh, I'm missing a connection on the back there. Right, just a minute, let me see if I can find it. Hang on. Right, I found it. I've got it here. It's I've been using it on DMX, so I can use so the last three connections are currently DMX. That's the ground, the G and the H connection on there. So I can quite easily use what's left, F. I can use F or E, so I'll use F for my connection. I'll do that. That's not much wire in there. Let's make that better. There we go, that's better. Right. Pop that in there. Okay, so I've got my signal going to here. I can put my plus 5 volts, which is on this connection. We can put that into here. And I can put my ground, which is this white cable, into this one. So I need these two, so I need another connector. There we go. So I need to put that one in. Didn't strip these particularly well, did I? Last time. Yeah, that's better. Right, stick that one in there. And then I need another ground to connect to this. So I need another wire. Here is another wire. Right, so let's stick that in there. I'm not happy about all that wire hanging off there, so let's just chop that down a little bit. There we go. Right, so second one in is ground. Right, okay, I'm just going to make a minor change to this 12 volt because there's far too much wire dangling out. I don't want it to short, so I'm just going to knock a bit of that off. That's better. Right, okay, so that's now done. So let's just do a quick recap. We have the ground going from here to here, which is then distributed between this, which I've just realised. There's the power cable. Okay, I made a slight boo-boo. I haven't. I've connected up the wrong cables for this. Let me just double check. Yeah, so okay. Bear with me for a moment. Disconnect that. Right. So what I've done, let me just explain what I've done. I've connected into the ground on the ground on here, but I haven't actually connected the power because the power's on a different cable. So let me do that now. That in there. Let me making a complete hash of this, aren't I? Right, let's do this better. That in there. That in there. That in there. And that in there. There we go, that's better. So I now have, as I was saying earlier on, controller. Power for controller is there, going to the ground, which is shared there. The plus, which is shared there. That's all going to be on 12 volt. The 5 volt is connected to this cable here, which is the earth cable that I nicked out of another cable, but that's the 5 volt side, which is going to here. But again, it's all connected on the grounds here, so we have to make sure that all the grounds are connected. That's it at the moment. So let us power up. We should get power on here in a minute, and we should also get power on here. So this will be running on 12 volts and this will be running on 5 volts. Or you'll see the magic smoke. Whichever. Let's power on. Power on the wall. Power on that. Yes. Okay. Testing time. Can't see that, can you? Can you see it there? Just. First of all, let's have a look at the controller. The controller is on, as you can see there. Let's just double check that this is 12 volts. Yep, that's, well, 11.1. That's 12 volts, that'll do. Next thing we need to do is to make sure that our LEDs are on 5 volts. There, and as you can see, 4.9. That's on 5 volts as well. Good. Right. What we need to do now is some sort of test to make sure that the LEDs are working. So I shall plug in the network cable to here, and I'm just going to go over to the PC and connect to the controller, which I think is 192 something or other. So let me just power off. There we go. Power on again. So what are we on? 192, 168, 200. Right, okay. I'm also going to put it in configuration mode by holding it down and going into that. Right, okay. Apologies for that little break. I had to just reconfigure a couple of wires, mainly network cables, on my desk so I could connect to this. It's in configuration mode, as I said. Network cables going in. We've got signal coming out here. We've got power being distributed by this board here, and we've got our LEDs which are running a simple test from the controller there. So again, these are running 5 volts, these are running 12 volts, and they're all running off this distribution board here. So there you go, that's a quick test of that board, and I'm going to assume, without actually wiring them up, that that board, and there it is, that board will be exactly the same. It's just that they have different types of distribution options on it. Personally, if I was going to use these, I would either use this one or this one, because they're both fused, whereas this one doesn't. But the advantage of this one, it has far more connections on it, either by the pins or the screw tip terminals, so you'd have to fuse this separately from that point onwards to the LEDs or the controller. So there we go, so that's that done. I'll just stop the camera again, and I'm going to set up another quick test, and then I'll come back to you in a second, because I'm going to connect that up as well to the 12 volts. So bear with me for just a moment.
A few moments later.
Right, okay, everything's wired up now, so I can show you what's going on. We have a transformer here, which is outputting power via the ATX to this breakout board here. That's giving me 5 volts, which is coming out on this old earth cable here, but it's 5 volts, so I know it's 5 volts. We've also got ground, which is going to this Wingo connection here, which is distributing the ground, and the red cable is giving us 12 volts, which is going out to here. So that's what's that powering. The 12 volt side is powering this, which is the ProOne, which we've got connected just in configuration mode at the moment. Also the 12 volt is going out to the SP901E, which is the amplifier and distribution as well. We've got one signal coming out of here, which is on channel F. That's going into the data in onto here, and also got the ground connected to the 901E. We've got 3 outputs, which is 1, 2, 3 here, which I'm using the data and the ground, which is connected into the 901E, and I'm using a 5 volt distribution here to distribute power to our LEDs. Okay, so let's have a look to see what I'm actually powering. Oh, and by the way, apologies, I realised that my microphone wasn't connected quite right previously. Hopefully you should be able to hear me a lot better now. So there's our controller, there's our power distribution, and there's our transformer there. And if we look above us, we have got one shelf there, another shelf there, and another shelf there, and there I are they are just on a simple pattern. In fact, just bear with me for a minute, I was going to close the curtain. Right, that's better. So now you can see the shelves are working better now. So we're just simply on a pattern, just a simple test pattern, as you can see. But what's happening is that the 5 volt feed is feeding the LEDs, and the distribution, the splitter, the 901E, is splitting that between the 3 different shelves, so they're all showing the same pattern. Let's go back on the desk, and we can see that the controller's here, the 901 splitters here, power's coming from the splitter board just there, and the transformers there. So there you go, that's how you can use a old PC transformer using a splitter box like that to control both 5 volt and 12 volt. So 12 volt there, 5 volt on the LEDs just there. Well, there you go, 3 different types, that one, and the one I'm using at the moment, whoops, that one there. So that's got fuses on it, that's got fuses on it, that one doesn't. So I hope you enjoyed watching that and learning a bit more about what you can do with old transformers. If you like what I do, please subscribe, and don't forget that this talking is making my throat dry, so if you want to buy me a coffee, there's a link down there. Thank you very much, please subscribe, that helps with the old YouTube, whatever the YouTube does in the background. Thanks for watching. Oh, and if you're wondering why I want 2 different power like this and I'm messing about with this and that, well, the answer will be in the next video. Thanks for watching.